Welcome to the podcast on roots and radicals. In this podcast, we'll be defining a square root, which we call a radical equation, and I'll be showing you how to work some problems in square roots, and in particular, how to use your calculator in working those problems. Let's begin with a definition of a square root. We're going to look at a definition of the nth root of x, and we're going to start the definition by saying, well, what happens if we're taking an odd root? What happens if n is odd? If n is odd, then the nth root of x, written nth root of x, that's this symbol right here, is the number you raise to the nth power to get x. This number right here, the nth root of x, is the number you put to the nth power to get x. So if I have right here the nth root of x, and I raise that number to the nth power, I have to get x. So it's kind of like the nth power canceled out the nth root, and you were left with the x. Now that's not really canceling. You know, canceling is something done top to bottom in a fraction. This isn't canceling at all, but there is a reversing that's going on. In other words, using the nth power is the opposite of the nth root, so it's kind of like they cancel each other out. Another comment, this number n is called the index of the radical, and this little symbol here, the kind of V with a long tail on it, is called the radical sign. And the number on the inside, the x, the thing you're taking the nth root of, is called the radicand. The radicand. Okay? Index of the radical sign, and the radicand is on the inside. Okay, we learned how to take an odd root. So if I'm saying let's take the cube root of 8, that would be the number that you would cube to get 8. Well, if you cube 2, you get 8. So the cube root of 8 would be 2. Okay, let's go on to the second one. How do you take an even root? Well, if n is even, and if x, the radicand, the thing in the radical, is positive, then the nth root of x, which is still written exactly the same way as you write it if it's odd. The nth root of x, there's the index, there's the radical sign, and there's the radicand. The nth root of x is the number you raise to the nth power to get x. So let's take an example of that. We'll take an even root, so I'll take the fourth root of 16. And that should be the number you raise to the fourth to get 16. Well, if I put 2 to the fourth, I get 16, so that number should be 2. Now, here's the catch. Note, if n is even and x is negative, then the nth root of x is undefined. So if I try to take, let's say, a square root of negative 16, now, let me make a comment here. If I don't put an index on the radical, then the index is too understood, and we call it the square root, okay? But let's just take the index off. So that's the square root. So n is even, it's square root. X is a negative number. This is undefined. Okay, with that as background, now distinguish that from this. If I put the negative out front, but take the square root of a positive, the square root of 16 is 4. That is, if I square 4, I get 16. And now I've put a negative sign in front of it, so I would get negative 4. That's okay. It's the negative inside the radical that you can't have. That's what makes it undefined. Okay, with that in mind now, I've lost some stuff here. Let me pause this. Okay, I'm back again. We got the calculator working. With that definition in mind, let's work some problems. The first one says, what is negative the square root of 121? Well, from your arithmetic, you can probably remember that 11 squared gives you 121. So the square root of 121 would be 11, so that would be negative 11. Now, let's see how that would work on our calculator. I'll move the calculator up a little bit to give me better access to the keys, and let's put that in. We start off with a negative sign. Negative sign is down here on the bottom. You can see the little arrow on the negative. And then we're going to put a square root. The square root is located right above the x squared key, and it's in blue. So I'm going to hit the blue key second, and then x squared, and that produces square root. And then I'm going to put in the number 121. Then I hit enter, and there's my answer, negative 11, the same thing we came up with. Let's try the next one. In the next one, it's negative the sixth root of 64. So the first question is, can we even take that root? Well, if the number is on the inside is positive, you can take the root, whether it's an even root or an odd root. It doesn't matter. It's only when negative numbers are on the inside that you have to look out for trouble. That's a positive number, so we're just fine. So I'm going to enter this pretty much like we have it. But I've got to tell you that your calculator can't directly make the sixth root from any key on the screen. So here's what we're going to have to do. I put in the negative sign as before. But to get the sixth root, I do the following. I go up to the math key to get the math menu. The math menu comes up and it says x the root. There is no sixth root anywhere on it. There is in this fifth position the x the root. So here's how we're going to have to proceed. Let me go back. I'll hit the clear button to go back to the main screen. I've got my negative there. To get a sixth root, I'm going to hit a 6, math, and then the fifth selection down right here is the xth root, so I'll hit 5. And look what I've got. I've got negative 6x the root. Now what that does is it takes the 6 and it puts it up there where the x is. So I've now written negative the sixth root. I put in 64, enter, and there's my answer, negative 2. And apparently anytime I'm going to write on the screen, it's going to erase my calculator, so I'll have to be constantly bringing the calculator back up. Let's take a look at the next one. In the next one, we have a negative on the inside. That's where we may have trouble. But you only have trouble taking an even root of a negative. Since this is an odd root of a negative, there's no problem. You can take an odd root of a negative. And, as we saw before, it is kind of like the fifth power removes the fifth root. That is, they reverse each other, so we just end up with negative 23. But just to make sure of that, let's go ahead and do it on the calculator so you'll feel confident with it. On the calculator, I want the fifth root, so I go 5, math, 5 for x the root. And there's my fifth root of. And then I put in the number negative 23. Now if you have a TI-83, it opened a parentheses. So you close the parentheses right behind the negative 23 because that's what goes in the radical. Whoops, and I left out my brackets. So I have to go back and put brackets in. So here's what I'm going to do. I'm going to arrow off to the left. Watch the calculator as it moves to the left. And right now the flasher is on the 5 and I want to move that to the right and insert an open parentheses. So right above the delete key it says insert, and that is in blue. So I hit second insert open parentheses, and there I've got it. I still have all my 5x root. Now with my arrows I go to the end, I close parentheses, which is right above the 9 here, and I hit enter. Whoops. No, I don't. I have to now raise that to the fifth power. So I come over to the little China hat looking key here. That's like an arrow pointing up. So it's going to take the number after it and put it up to make it an exponent. So to the power 5, enter, and sure enough I get negative 23, just as we thought we would. Let's go to the next one. In the next one, again, I have a negative number inside the radical sign, but this time I'm taking an even root. And if you read the sign here, I'll get it out of the way, you can't take even roots of negative numbers. That's what all that fancy definition boils down to. You just cannot take even roots of negative numbers, so this should not work. But I'm going to try to put it in just like the one before. So I'll go open bracket. I want to do a fourth root, so I'll do 4 math 5. That's 4x root, or fourth root. I'll put in the number, negative 23, and close my bracket. And then I'll put to the power 4, and then I'll hit the enter key. And sure enough, we shouldn't have been able to take an even root of a negative number, and when we try to take the fourth root of negative 23, we got the message error domain. And what that means is, if you're taking a fourth root, you can't put in negative 23. That's what they mean by error domain. Now, let's contrast that with the next problem, though. So this one is undefined. But the next one should be defined. I am taking the fourth root. There is a negative, but it's not inside the root. It's outside the root. So this one should be okay. I have no idea what number you raise to the fourth power to get 23, but let's go ahead and do the problem anyway. To get back to our main screen, we hit the clear button. We're back on the main screen, and now things are getting crowded, so I'm going to hit the clear button again. Now we got an empty screen. Let's give it a try. Open bracket. We're going to do a fourth root, so 4 math 5. That gives us the x root. Now this time we want to put in positive 23, so this root should work. Close bracket, to the power 4. And we know what we should get, because the fourth power should cancel out that fourth root. And when you raise a negative to the fourth power, that should make it a positive. So what we're expecting to get here is positive 23. The fourth power will get rid of the negative, and the fourth power will reverse the fourth root. And all that should be left is 23. And sure enough, there it goes. The calculator gave us 23. Okay, let's do one that gets a little bit more complicated here. Not real complicated, but a little bit more. We're going to do number 5 here that says 2 to the 5th power times the 5th root of 243. I happen to know the 5th root of 243 is 3. 2 to the 5th power, that's 32, so hopefully here we're going to get 96. Well, let's go ahead and give it a try. First we put in 2 to the 5th power. 2 to the power 5. There's our 2 to the 5th power. Now we're multiplying it by this root. I don't want to just put in another 5 in x root, because that's going to look like 2 to the power 55. I don't want that, so I'm going to put a times sign in here. Times. To get the 5th root, I go 5, and then I want the x root, so I go math 5, and that gives me the x root. So right now I have 2 to the power 5 times the 5th root of. Okay, we want the 5th root of 243, so I put in 243. Again, if you have a TI-83 or 84, it opened a bracket here. And all you want in there is just that one number, so you want to immediately close that bracket. Let's hit the enter to see what we get. And we do get 96 just as we thought, so I'll put it here, 96, and sure enough, that erases my calculator again. Now, what happens when you're dealing with approximate numbers? How do your rounding rules go? So let's check into that now. I'll move my screen up a little bit so we can see the rest of the problems here, and I'll bring my calculator back, move it up, and I'll go ahead and clear the screen. We're starting a different topic, which is approximate numbers now. And if you recall your rounding rules, the only time you ever round by precision is when you are doing adding and subtracting. Well, we're taking a square root, so we're going to round by significant digits. Notice there are 3 significant digits here. So let's go ahead and get started. We want the square root, so I hit second x squared for the square root of, and it's a single number, so I just put 0.0627, enter, and I get this huge number. And I just erased that huge number. And that huge number is 250,399, or at least that's the way it starts. 0.250399. Well, remember that in my radicand I only had 3 significant digits, so my answer has to go to 3 significant digits. So my answer is 0.250, because the next number over was less than 5. Okay, let's try another one. This one's a little bit more difficult, and this time I'm not going to be able to fit all these numbers into that little single radical that I get like this when I turn my calculator on. So what I'm going to have to do to cram all that in there, I'm going to have to do an open bracket. Of course, you won't have to do that if you have a TI-83 because it's going to open the bracket automatically. Plus 2.1609, and then when I have everything that I want in my square root, then I want to close that bracket. So you want to be sure, if you've got the TI-83, that you also close your bracket right here. Okay, let's go ahead and do the computation. By the way, we got to do a rounding. We got to figure out what our final rounding be. Now notice on the inside we're doing a plus. That means we're going to round not by significant digits but by decimal position. Well, this number is precise to the 10,000th. This number is also precise to the 10,000th. So inside of the square root, we're going to have a number to the 10,000th. Now, what will that number be? Well, 2 plus 10 is 12. So it's going to be a number that's bigger than 12. Let's say 12 point, and it's going to be to the 10,000th. So I'm just going to pull some numbers out of the air. I'm not going to compute. I'll just pull them out of the air, but make it to the 10,000th. So I'll say 7013. That number is to the 10,000th position. Notice that's 6 significant digits. So I'm going to have a final rounding. When I take the root, my final rounding has to be 6 digits, 6 significant digits. So let's go ahead and do the problem. Bring the calculator back. I want the square root of, so second x squared. I want an open bracket to cram all of this in. 10.6276, 10.6276 plus 2.1609, 2.1609. So let's see if we got it in there. 6276. 1609 looks correct. Close bracket, and we hit enter, and we get this long answer, 3.576101. Now remember that we are rounding to 6 significant digits, so that's going to be 3.57610. There's my 6th digit. The next digit over is a 1, so I'm going to leave that as a 0. Now the trick here is going to be to try to remember a number that long. 3.57610. 3.57610, and there's our answer to that one. Rounded to 6 significant digits because the material on the inside when we added gave us 6 significant digits. Now let's do the same problem, but this time break the radicals in two to see, do we get the same answer? So I'll bring my calculator back up. I'll enter the first square root, second x squared. I'll put in the number 10.6276, 10.6276. Don't forget to close the bracket on a TI-83, plus the square root of 2.1609, 2.1609. There we add the square roots and we get 4.73. Man, that's a different number, isn't it? That's not anything like before. And that's because the square root of a sum does not equal the sum of the square roots. You can't do this square root by breaking it into 2 square roots. We got 3.5 something before. Now our answer is 4.73. Now, how many digits do we get? Well, that's kind of tough. We get 6 digits on this answer. And we get 6 digits on this answer, but we don't even have 6 digits. We only have 3. So the most we can keep here is 3. So we'll just say equals 4.73. Okay, let's go down now and do a word problem. Interesting little word problem here. It says the speed in meters per second of sound in seawater. So how fast does sound go in seawater? The speed of sound in seawater is given by evaluating the following. the square root of b over d. B in this case is 2.18 times 10 to the 9th pascals, and D is 1.03 times 10 cubed kilograms per meter cubed. You don't really need to know all those units because he's already told you how the answer works out. It works out in meters per second, so whatever answer I get is going to be meters per second. So what we want to do is we want to do the square root of b over d. We want to do a square root of the number b, 2.18 times 10 to the 9th, over the number d, 1.03 times 10 cubed. And recall back when we were doing scientific notation that we said normally the notation we like to use is the E notation. So if I put this into my calculator in E notation, here's what it would look like. I'd put the square root of 2.18 E9 times 1.03 not times, it's divided by, isn't it? Let me go back and erase that. It's divided by. And I can't use a long square root like that if I'm doing a calculator. So I'm going to have to get them both into here. So I'm going to have to use an open bracket. I'm going to go to an E notation on the first number, 2.18E9. Then I'm going to put in a divided by. Then E notation on the second number, 1.03 E3. Close. And let's see what we get. I'll bring my calculator back. Holy smoke, it's still on. Okay, we'll clear. Let's put it in. We want to get our square root sign, second x squared. We want to open bracket because we've got a lot of stuff to fit in here. 2.18E9. 2.18. Now remember to get an E for scientific notation. Above the comma there is that symbol double E, and it's in blue. So to get an E, I want to go blue double E, or blue comma. Second comma. There's my E. And then it was E9, so I put in a 9. Then it was divided by. Now you might say, well, don't you need a bracket around the 2.18E9? No, that's why we're using E. If you use the E notation instead of the times 10 notation, the calculator inserts a parentheses invisibly around the 2.18E9. That is, it connects the 9 and the 2.18 to the E symbol, so you don't need a bracket. So let's put the bottom in. That was 1.03 E3, so 1.03. Again, to get E, double E is here above the comma. It's blue. So I hit the blue key and the comma key, and that gives me the E3. Then I close the bracket and enter. Now before we do this, what kind of answer are we expecting? Well, 10 to the 9 over 10 to the 3 is 10 to the 6th. And if you square 10 cubed, you get 10 to the 6th. So I'm expecting something times 10 cubed, which would be an E3 answer. So let's see what we get. Well, we get a big long answer in regular notation. Now, if you want that to be an E3 answer, if you want to see it in terms of the E notation, you could just go to the scientific notation mode. You'd hit your mode key on your calculator. You'd go up here and change the cursor to where it was over scientific, so you'd arrow to the right and hit enter, and that would keep the cursor there on scientific notation. Then when you returned with the clear button and you execute that computation again, and to execute it again, you just want to recopy the problem. So you'd go second enter. That would recopy the problem. And now you're in scientific notation, so your answer should come out in E notation. Hit enter, and you get the answer 1.4548 E3. There's your E notation. You got that by going to scientific notation. Notice that this number and this first answer are the same, because if I change this one to scientific notation, I'd have to move the decimal 3 places, so that would give me 1.454 E3 also. So I've got this E3 answer. How many digits do I get? Well, the digits are determined from the base. So I have 3 digits in this base, 3 digits in this base. I'm dividing, so that's by digits. So this division gives me 3 digits. Then I take a square root of 3 digits, so that gives me 3 digits. So my final answer is going to be 1.45 E3, because if I look at the next digit over, it's less than 5. So I don't round up. So my answer is 1.45 E3. And that completes the podcast on roots and radicals.